10
Yep.
minutes. That's okay. All right.
My fault.
Just too excited to learn. So that was Webb's actual separation, and very, very exciting to see, even see that solar array deployment, and pretty much immediately learn that it had power. It's on, it's live, it works. And I believe today they just confirmed that the sun shield tension has gone well. So the layers of the sun shield are deployed and tense, and it's all working. So exciting. And this is what Hubble's mirror looks like. So it's much, or not Hubble, Hubble and Webb, it's much more massive than Hubble. So very, very interested to see what kind of images we get, how they'll look. And, you know, we're almost tripling our mirror size. So hopefully by the time they unfold the mirrors and kind of start adjusting them, that all goes well too. So we're just sending this massive, massive telescope 1 million miles from Earth. And the best part is that data, when we finally get it, if everything works, anyone can download it and use it. So hopefully we'll be processing data from the Webb telescope as well. But Webb is a bit different than Hubble. It is going to see mostly in infrared, mid-infrared, and near-infrared wavelengths of light. It's going to have 4 science instruments. I'm very interested in the near-infrared camera to see what we capture. Images are going to definitely look a lot different than what we see with Hubble. So using Hubble images as an example, this is kind of what we can expect to see is images like what would be on my left, probably your right, the more kind of starry images, at least for a nebula. So the image with the kind of rainbow is how it looks in visible light. So we can't really see anything. It's really, really dusty and there's a lot of gas and it's just opaque. But when we image it in near infrared wavelengths of light, we can suddenly see all of these stars, which most of them are actually behind the nebula, not inside of it. But it also allows us to then kind of peer through that dust and gas and kind of see like what's going on in there. As these stars are forming, can we kind of figure out what's happening? Some of it is definitely still very opaque and we can't even pierce that, but hopefully Webb can get in there and look a little bit deeper, as star formation is one of the things that it will be looking at. So here's another example from the Hubble Space Telescope. This is the pillars of creation. So again, imaging it in near infrared wavelengths of light, you can just see so much more activity going on in this nebula. So Webb will hopefully be able to kind of start giving us a lot more answers about things like star formation, what's happening at the beginning of the universe, how galaxies formed, planet atmospheres, and pretty much everything that we can't see now. But we're not just going to get rid of Hubble. Hubble is hopefully going to stick around at least till 2030, hopefully 2040, if not longer. That would be absolutely amazing if it could just last just as long as it could. It has just gotten us so much amazing data, and Hubble and Webb are going to be friends in the sky.
The Hubble Space Telescope and the James Webb Space Telescope will complement each other in the study of celestial objects. They are different sizes, will be at different locations, and have different instruments that cover different wavelengths. but together, they will help answer some of the most fundamental and inspirational questions that we have about our universe.
All right, so now that we've got a little bit of background on these two amazing telescopes, I'm going to talk about how I create these images from the Hubble Space Telescope. And then at the end, I'll kind of show you guys some websites that I use and my processes. So Hubble, as I mentioned earlier, is all mostly visible light, a little bit of ultraviolet, a little bit of infrared, but mostly visible. So it's a little bit easier to kind of match as to what we would see if we could look at it with our eyes. But it's not always going to be true color. So this is the wide field camera 3. This is the main instrument that we now take photos with on Hubble. It's been upgraded a few times, and it currently has 62 ultraviolet and visible light filters, a little mixture of each, and then 15 near infrared filters. So you kind of have to understand how the filters work in order to understand how to colorize your photos. But everything taken by the Hubble Space Telescope is black and white. So if you are familiar with astrophotography, if you do monochrome imaging, narrowband, you're probably familiar with the black and white. When I first started out, I had a color camera, just a normal digital camera that I stuck in the back of a telescope, so everything came out color. And then I had to kind of learn how to process color and then eventually how to process narrowband, which is what Hubble does. So this is how images look when you download the raw data. It's black and white, and then each filter captures a certain thing depending on what you're trying to capture. Most filters are visible light, but some do go into ultraviolet and infrared. So the first set, this is the antenna galaxies. It is a set of 4 images, and they essentially each get colored and then stacked into a single image, which I'll go over a little bit about later. So the first image that I download has the 814 filter. This is 814 nanometers. And if you're to pull up the electromagnetic spectrum, this would be closer to the red end. So we color it red. And the reason that we're going to color it red, green, and blue is because it mimics the cones in our eyes. So we have red, green, and blue cones. So we're trying to kind of mimic what we would see and kind of create that natural image, as well as that's how like computers and cameras and electronics work in red, green, and blue. But don't ask me about that. I'm not an electronics expert. I just make pretty pictures. So the next filter is green 555. Some of the filters from Hubble don't always correspond to the color wavelengths, so you can take liberties with what you color them. We usually kind of just try and match the closest that we can. The third one is 435. This one is closest to the blue spectrum. Might even be going into purple a little bit. And something that if you process a lot of these images, you'll notice is the filters actually show different things. Like some might be really fuzzy and kind of hazy, which is capturing a lot of that dust and gas. And some might be more sharp. Some might not even capture a lot of the object. So you can kind of see here how just in this image, it captures a little bit more of those nebulous areas. And then here it's kind of more hazy. It doesn't capture that nebulosity as well. So this is my last filter. This is a 658 hydrogen alpha filter. This specifically captures hydrogen alpha wavelengths of light. And then when you combine them all and do a little bit of extra editing, you get a full color image. So it's very similar to amateur narrowband data where you combine the different filters. Most people I think use like sulfur, hydrogen, oxygen, but it does take a little bit different practices when you do it in Photoshop. Hubble data is actually a bit more clean, so it doesn't always need as much as an amateur photo might. So we don't just you know, stack the image together and get a pretty picture, we also have to do a bunch of different things to it. We can do anything from first colorizing the image, and then we have to stack it. We can enhance the colors. We can do contrast enhancement, you know, change different levels, clarity, texture, like anything that this photo needs, we can do to it. And sometimes they don't always come out scientifically accurate. The rainbow nebula are not rainbow. They would be mostly red, but you know, we can take certain liberties with it. If you are going for scientific, cool. But if you just want to have fun with it and make pretty pictures, you can do that as well. So this is kind of what the flow looks like from start to finish. You have all your black and white images together. You colorize each filter separately and then combine them all into one image. So I use Photoshop. You can also use GIMP, which is free software, or PixInsight, which is more geared towards astrophotographers. I'm still learning how to use PixInsight. It's definitely very different than Photoshop. My friend tried showing me, and even just editing his amateur data versus Hubble takes different steps. So it's like kind of tricky to learn, but once you get it down, it's really, really easy. So there are two archives that you can get Hubble data from. The first one is the easiest to use, at least in my opinion. It is also the first one that I worked with. This is the Hubble Legacy Archive. So I did provide links to Bob, sorry, Robert, right, in emails, Robert Bob, and he has all the links. I'm sure he'll post them as well.
I plan to put them out on an email tomorrow and have Bob or somebody put them on the website. So you'll all get them tomorrow as a broadcast message. So
the Hubble Legacy Archive, I will pull up at the end of the presentation and kind of show you guys a little bit how to use it. I also do have YouTube tutorial videos on how to use it, or you could just email me as well. I'm always happy to chat about Hubble data. It is amazing. And then the other archive is the MAST portal. So this one is the newest archive. It has the most up-to-date information. Sometimes you will find images here that are not in the Hubble Legacy Archive, but it's a little bit trickier to use. I actually just figured out how to use it a few weeks ago. But if you want the most up-to-date data, this is good. So I'll also show how to use that a little bit. And I wanted to show you an image from start to finish. So this is going to go very fast. It's just kind of meant to show the whole process without really going into too much detail, just to kind of see what goes into making an image from the Hubble Space Telescope. So this is Photoshop CC 2020, and I've already downloaded the images and I just upload them straight into Photoshop and go for it. All right, so that was a very fast run through of what these images take to create. It can take anywhere from maybe 30 minutes, or if it's a really complicated image, I can spend a couple of hours on it. Depends on how inspired I am. Sometimes I don't even finish it and I have to come back to it days or months later, and then I finally can finish it. So I just wanted to share some of my images and then go a little bit of detail about how to download these and what you can do. So this is, I believe, NGC 1672. I should have put the names on here. But this is a galaxy that I just recently processed. And it's kind of fun as you learn this because you'll notice like your progress over time. As I compare images when I first made them to now, and I totally should have put that in here. And you can definitely see progress, so it's really fun. This one is the Cosmic Reef Nebula. I know the one in the corner, I think, is NGC 2020. I can't remember what the other one is, but there's a bunch of amazing data. This is AG Carinae, which is a Southern Hemisphere star. You can do globular clusters, like you can kind of download a little bit of everything. Like there's Herbig-Haro objects, there's galaxies, nebula, love peculiar galaxies. There's some of my favorite to process. But there's not just Hubble data that can be processed. So if you're interested in processing data from NASA, I think pretty much any mission that has data that's publicly available, you can download. So one of my favorites also is JunoCam from the Juno probe that's orbiting Jupiter. You can actually download this data as well and play with it. This is a picture of Jupiter that I processed. It's a little bit different than processing Hubble data. So I need to make some tutorials on that one. I don't have those on YouTube, but getting to download the Jupiter stuff is just amazing. JunoCam is one of my favorite places to download from. You can download from any of the Mars rovers. I believe these are just single images, so they're not as fun to play with, not as easy to edit, other than just like coloring them with one color mostly. But you can download this data. You can play with it. You can have fun. You can kind of see what we're looking at on Mars. So it's just really, really exciting. And the best part is once you get into professional data, you can download it from any observatory that has data, like any place. Subaru Telescope, Southern European Observatory, Liverpool, Spitzer, Chandra X-ray, like anything NASA and any observatory you might know that is huge public observatory has data available. So that is really, really, really exciting. It's definitely a learning curve to figure out what each observatory, like how to download the data and how to process it, because they all have different cameras. But this is my most recent image from the Subaru telescope. had just gone into this archive. Super, super, super excited about this because this image I came across when actually looking at the lower, my left, your right. Let me just come over here and point out real quick. So it's a little tricky to see in here. It's really teeny tiny, and I have a much larger image of this, but this is HH34, which is a Herbig Haro jet. So this little baby star right here is kind of shooting out a jet of radiation. And as that radiation is hitting the gas and dust in its path, it's lighting up and emitting light. So we see it as this jet of radiation, and then it creates this kind of bow shock at the end here. So I was actually looking up information on this image, and I came across this image. And this up here is Herbig Haro 222, and what's coming off it looks like a waterfall. So this is known as the Orion streamers, and I read the paper on this. I actually reached out to the researcher who is very prominent in star formation, very cool. And I asked him, like, have you guys figured out what this is yet? And they haven't really figured it out. So they know that this Herbig Haro jet up here, those are bow shocks coming from a star that's like way down here that we can't see. And it's just shooting out radiation, and it hits that gas and it creates those bow shocks. But they still can't really figure out why these streamers are happening. They say it's like, he explained it as hose hitting, like the water from a hose hitting a wall, and how the water can splash off sideways, but there's like nothing really there that's like making it splash. So it's really interesting, super cool mystery. I would totally love to get my PhD just to figure out what that is. But yeah, I basically hunted down the photo. It said, hey, we took this from Subaru. I went down to Subaru. It said, here's your public archive, register and download the image. So really quite cool what you can do with professional data. I'm sure it's even better for scientific purposes, but you know, I like it for the fun purposes. So let me close this, and then I will show you some of the websites. I don't know if I can minimize Zoom. Let's see. Maybe I'll just type it in this tab because I don't know how to minimize the screen. But this first website here is the JunoCam, and this one, so I'll just kind of show you guys like what some of these images look like before you download them and make them pretty. So unfortunately, JunoCam only has JPEG images. One thing about astronomy data is that it all gets downloaded as a FITS file. So FITS, that is the standard in astronomical data. It contains like the data image, but then a bunch of all this other stuff that I'm not too savvy on. But it essentially downloads as that image, and then using Photoshop, using the FITS liberator, you convert it from a FITS file into a TIFF file, and then you can bring that into Photoshop. Because Photoshop cannot read FITS, it can only read TIFF, JPEG, PNG, all the basics. PixInsight can read FITS, but not Photoshop. So unfortunately, JunoCam is only JPEG. I just find that it's not as good of data, a little harder to work with, but still really, really cool. So you can essentially say, I want to download this image from Jupiter. You can kind of look at it, see what it looks like, and then you would just click the images button and it would start downloading. These do come in red, green, and blue like Hubble, so it kind of makes it easy to put together. All right, so this is the Hubble Legacy Archive, and I do have YouTube tutorial videos on how to download and what to download. So kind of just show you like what the images look like from the Hubble telescope, because some of them can be pretty dirty and a little bit tricky to work with. So using one of my favorites, look up the Eagle Nebula. In this case, it's mostly focused on the pillars of creation, but The Hubble Legacy Archive makes it very, very easy to search for these images. You instantly get a view of what you're looking at, and you don't have to try and like look at this little map that the MAST portal has. So this object is cool, the Pillars of Creation. The first files here can see they're titled Heritage. So this means that they're actually put together by the Hubble Heritage team and kind of saved in this archive, because they're actually like separate images that they kind of stitch together and make into one image. So they kind of clean it up and make it pretty and then put the file for you to download. Not all the images are like this, which is really sad because some of the images are so hard to figure out and you actually need to know a little bit of Python coding in order to do it. But I'm learning that, so one day. But this one here, this is the first row are the infrared images that I had in my presentation. And then the second row are the visible light images. This is the 2014 image. And then what's really cool is they have pretty much everything. So this right here is one of the first iconic images that they released. So this is kind of the image that they put together and showed to the public, and the public was like, wow, we can see really cool things in space. So it was so cool to get to download these images and process them, because it's like, wow, this is the thing that made Hubble famous. And now here I am 30 years later, when I started downloading this data, being able to play with it myself. So it's really quite cool being able to get into astronomy and kind of work my way backwards and go through this old data. So this is what this archive looks like. And some of the files are very large, some are small. So if you have older computers, it might be hard to work with. But you essentially just download it and then you can throw it in Photoshop after you convert it. And then I will pull up the MAST portal. So the MAST portal is not just Hubble. It also has pretty much not every telescope. It has a couple other major telescopes in there. I know Spitzer is one of them, but the files don't always look the same, so it's tricky to work with the data. Let's see, what would be a good one? Do the antenna galaxies. So MAST is definitely a bit more updated. It has different things, which I'm sure if you wanted to play around, you could kind of figure out. But you can see here that the image preview is not as pretty as the Hubble Legacy Archive. It kind of shows like everything, like all the outlines of the images. But over here in Mission, if I just wanted Hubble, I would choose HST. And HLA, it actually has the photos that are in the Hubble Legacy Archive in here as well. So it's just got everything. So now it's a little bit easier to see, but if you still really want to figure out like what the best image is, it's kind of tricky. So I don't use it as much unless I absolutely have to, but it's definitely a more advanced portal to download images from. And one last thing I will show you before taking any questions is my YouTube channel. So I actually started it despite being very self-conscious about having to listen to my voice and like edit videos, because I've never done that in my life until I made YouTube. But the reason I made this is because there is, I think, one video on how to process data from the Hubble Space Telescope, maybe a couple others, but it's also not geared towards like beginner. Like when I started Photoshop, I literally, when my friend taught me, I had to say, no, show me the exact button, because I have no idea what you're talking about. So I was actually able to then take his steps and convert every single step into its own video, and then put together actual flows for how to create a Hubble image. So I go through things like, I'll just play a clip of a video.
With Mountain's Customer Journey Builder, you can connect with more customers and leave them and their
Turn
great
that
friends.
down.
In this
So,
tutorial, I will be going
yeah,
over how I
I'll
process
mute that too.
NGC.
But basically I kind of go over like what files I download. I also have a video for which files to download. There's so many steps to this when I like think about it. But yeah, I pretty much show you like how to download it, how to convert it in FITS Liberator, and then using Photoshop, like how to bring the images in and process them. I don't always go through the full tutorial of like, you know, first I do this enhancement and then I do that. I kind of just say like, once you colorize it, boom, that's your turn now. You get to do whatever you want to it. But it's definitely helpful for some of the trickier images that are just very confusing. So I will wrap up this presentation by just saying that this data has literally changed my life. So I'm a biology major. I worked in the microbiome labs at ASU. I was totally into like, you know, biology, microbiology. But then when I graduated and got my job and found astronomy and then joined the clubs in 2019, I found the Hubble data. And once I started doing that, I found I was actually pretty good at it. Like the amateur stuff and buying a telescope and, you know, finding what gear, like it was really expensive. I didn't know what to do. Like no one, it's like people are helpful, but they're not the most helpful. You know, they usually say this gear is best, but you know, the gear can be expensive. So when I learned about this and I started downloading it and then someone actually taught me how to use it, it was really cool to be like, wow, this thing that I've been struggling with for like a year, I understand how to do it now. And I wanted to be able to teach that to other people as well via YouTube, or if they message me with questions. And because there were things that I needed to know, like for the really difficult images, you need to know a little bit of Python and how to code the image to essentially stitch it together and create a final image. So I said, all right, I'm gonna learn Python. And then I said, well, if I'm gonna learn Python and I'm not really happy with my current career, I'm gonna go get a degree in data science. So I'm actually starting my degree to become a data scientist. I'm gonna learn how to use Python to really unlock Hubble processing. And I'm just super excited for the future. So if you guys have any questions about this, let me know. And if you have questions afterwards, like, you know, past the meeting, I can provide my email if you are very interested in learning. Yeah, it's amazing data to work with, and I'm very happy that I get to do it.
We have questions here, or I guess people on the web can unmute themselves and ask the questions yourself.
Yeah, let's see.
I have a question.
Yeah.
So you started doing all this in Photoshop and you mentioned PixInsight. As you're learning more about PixInsight, do you see you stopping using Photoshop in the future and strictly using PixInsight, or is it better to do like the first half of the processing and PixInsight, the back half in Photoshop, or what have you learned or what have you experienced so far between those two software packages?
So I'm very eager to see what PixInsight can do. The few lessons that I've had and what I've learned, we tried it with my friend's data and then we tried it with the Hubble data, and it didn't quite work the same. It almost seemed a little bit easier to first kind of combine the images in Photoshop, like color them red, green, and blue, and then make the minute adjustments that, like, if your core is blown out and really bright, PixInsight's really good at like dampening that and making it look good. So I'd say that I'll be end up doing both, probably start in Photoshop and then clean it up in PixInsight.
Because like what I've heard you say about the Hubble data, that's kind of like what we would call calibrated data already.
Mhm.
And when you start with the raw data where you just have your red, green, blue, and a luminous, and you have your flats and your darks and your biases, and you're gonna put all that together then, that seems to be, Pix Insight seems to have a lot of, one of the softwares to do that. Other people use Deep Sky Stacker, and I
Mhm.
think some members of the club use a program called Surreal that I personally don't know anything about, but it just seemed like, that first half where you just have all the raw data, there's a lot to that before you can start just putting the things into Photoshop.
Yeah, luckily Hubble data is very, very clean. So it's mostly you have your 3 or 4 or however many are in your data set, and you just combine them. So it's almost like easier to kind of do all that and then start working with it. When I tried it in PixInsight, it didn't work very well, but I only tried it once. So it could, it just needs some tweaking, because it's definitely a lot different than trying to process amateur data. It just needs a lot less. Like, you don't even need to use Deep Sky Stacker. You just stack them in Photoshop. So yeah, we'll see how that goes as I keep learning. Yes.
Yeah, is there a reason why NASA is using FITS? It's kind of an oddball format. You have to convert it. Is there any benefit to it being in that format? And when you convert it, do you lose any of the resolution?
So from what I understand about FITS is that it contains a lot of information about the image that I don't quite understand, like extra things like coordinates and just a bunch of like metadata that are helpful when you're doing like scientific stuff with the images. So I don't know between converting FITS into TIFF how much it would lose. I think it also kind of depends on the amount that you stretch it in the FITS Liberator, because as you convert the image, it kind of shows you the graph of the image, and then you can kind of stretch it how much or how little you want included in it.
You mean like
But-
histogram?
Yes, it shows a histogram. So I've never really seen any degradation, but I can't really view FITS anywhere other than in the FITS Liberator, other than PixInsight. But since I don't ever use that, I don't really notice a difference. But
I think if you import a file into a FITS file into FITS Liberator, there's a tab there that allows you to see the metadata. It flips it from the picture to the metadata. So you could go take an example and see what the metadata is. And all I know is there's a lot of it there. And, so I think once it goes to TIFF, that metadata is essentially flushed.
yeah.
But I don't think it's quote unquote meaningful to the artistic approach to it. So. And again, FITS Liberator is free too.
Mhm.
Any other questions? Any questions out there amongst the? Oh, I'm sorry.
Does University of Arizona have data available to the public?
I'm not sure about them. I haven't looked into any of their observatories. Like, I know that I think like Lowell and those up there don't. So I'm not sure if Kip Peak would, but hopefully, because I know that I think a while ago they used to do like public tours, and they had classes that you could go to where you would actually like stay there and learn and then image with their telescopes, but I'm not sure how much of that is public. So you can always ask them.
I'd like to say thank you very much for your program. You made it simple English. I understood what you were talking about. And it opened up a whole new world that I had not understood about this area in astronomy and what was possible to do as an everyday person. Thank you very much.
Yeah, I'm glad you enjoyed it. It's
Very much.
this data it's not just fun to play with and make pretty pictures. You actually do start learning as you go through it. Like when I process a galaxy, I can say, oh, hey, this red area is nebulous area, or this blue cluster is a young star cluster. So it's like you start recognizing things as you put photos together, and then as you learn about the backstory of the photo, you can then teach others about it. And it's just such a cool thing to play with. Like I had no idea that, it's all free too. So you don't have to, other than paying for Photoshop or PixInsight, it's a lot cheaper than buying a telescope. So.
So, any other questions? Last call.
Do you print any of that stuff out and have pictures all over your house?
That is the best part because it is Hubble data. It has, some are small, but most are massive files. So you can get really, really, really good detail when you print the images. I've printed on canvas, just normal photo paper, metal, and you can just pretty much print anything and it'll come out amazing. So super exciting about that too.
Talking to me? Yes?
What?
Was that a question?
Reims, if you know where Reims is, it's just opposite the hospital.
I think they're carrying on a conversation. Any other questions? Well, then, thank you very much, Alex, for the great presentation and for coming over to this side of town. So,
Yeah. All right, so I will get logged out of here and let you
Okay.
get on with your meeting.
as a side note,
Okay.
you haven't stopped Zoom yet, have you?
No, it's still
Okay.
going.
As a side note, I've started to play with this, but I'm using GIMP, which is again free and it's a very steep learning curve. So I think Photoshop is too. So, but I'm having fun and it's essentially free. All you got to do is have a little disk space on your computer and you can play around with it. And to me, it's one of the significant legs of astrophotography. So I'm essentially starting at the one end and trying to get my skills there. And then I'll pour some money into it to be able to take the pictures myself. But if I can make a pretty picture for my wife on the wall, I'm going to stop right there. So, all right. Okay. I think everybody's aware that Bob is quarantining, and because he is not logged on tonight, I suspect it's more than just exposure to COVID. So I don't really have any business to carry on here. If as you came in, if you haven't paid your dues, we have some volunteers that will gladly take your money. And does anybody else have anything? John, do you have anything to report? Or
I am working on kind of a new scheme for outreach for next year. And I contacted both Peoria Library again, which we did last year, and White Tank Mountain Library. And they were very interested in hosting us for some outreach activities there. And then I'm going to also work on City Surprise. I haven't contacted them yet, but the library seems to be kind of a good way to go as far as getting some support. I contacted City Surprise, and cities just aren't set up for what we do outside of showing up at the park, which was how we did our international observatory, which actually was great.